In this lesson video, we're going to look at how to determine the resultant of two vectors using a graphical method. Let's start with a super quick review. Scalars have magnitude only, vectors have magnitude and direction. Vectors such as velocity and force are represented using arrows, and the longer the arrow, the larger the magnitude of the vector. Arrows have arrowheads on them, obviously, to show the direction. If this blob moves 3 centimeters up, then 4 centimeters right, it will have traveled from the start to the end a distance of 5 centimeters. We can calculate that using c squared equals a squared plus b squared, with a and b, 3 and 4, giving us 3 squared plus 4 squared equals 25. So c equals 5. Or we can grab a ruler and measure it. It's 5 centimeters if we drew these to scale. Now, the focus of this lesson video. Sometimes the vectors are not at right angles, which makes the maths harder, but still possible. Sometimes there are more than 2 vectors, so harder still. Sometimes they're moving in 3 dimensions, harder still. The graphical method avoids the difficulties of the maths when it gets complex, and you need to be able to use it. Here's a couple of methods. The parallelogram method, or tip to tail, takes a protractor and careful drawing. I don't like it much, but here you go. If I have 2 vectors like this, with an angle around 30 degrees between them, I simply draw an identical vector at the tip of this one, and an identical vector at the tip of this one, giving me a parallelogram. The resultant vector is the diagonal, here. Now I just measure it and I'm done. Personally, I prefer the compass method. So, the same starting vectors. I take my compass and set it so it has the length of one vector. I then place the compass at the tip of the other vector and draw a circle. Repeating this, I set it to the length of the other vector and draw a circle like so. Where the 2 circles cross is the endpoint of the resultant vector. So I'll draw that in, and it's done. If there was a scale such as 1 centimeter equals 2 newtons, I need to write the scale down and do the final calculation to get my final answer. Now that seemed a bit more complicated, so why do I prefer this method, you may well be asking? Well, the first method had me using rulers and protractors, and that gives me plenty of places where I can go wrong, where I can introduce a small amount of error. This second method is just using a compass, which not only reduces the number of places to have human error, but the sharp point also makes it pretty precise. It just tends to give better results, and that means something to me. It'll take some practice, and some people start off by getting the compass the wrong way round and not quite getting the circles in the right place. But if you give it a go and learn how to use it, you should be quite impressed with the quality of the results you can get from it. And then, once you've finished, make sure you remember to convert it back to the vector units. Don't just leave it in centimeters like what you measured, and always put your scale on the diagram as well, otherwise you can lose marks for that.